Hello, AP Statistics. This is section 1.3, describing quantitative data with numbers. Okay, now before we begin, here's what I need you to do. You need a graphing calculator. You need your TI-84. I'm going to show you how to do some steps with your TI-84, which will make today's work a little bit easier. All right. If you have a TI Inspire, you may have to Google how to do these steps in your Inspire in order to get the results that we get. Okay. So take a minute, hit pause maybe, and go get your calculator, then hustle back, and that way you won't get behind on this lesson. All right, so here's what I got. Perry Football has a fundraiser called the Gold Card, okay? And within this Gold Card, they get buy one, get one free Blizzards, and that is the primary reason why I get this card, okay? Now, here's what we did for the last 11 months that this card has been available. We went to Dairy Queen, and we figured out how many people use the card within a month, okay? And the data that you see here represents the 11 months in terms of how many times the card was used, okay? So maybe this was September of last year, then October, November, December, January, February, March, April, and so on. And then, of course, the card expired, okay? I'm asking for three things here. I want the mean, I would like the variance, and I'd like the standard deviation, okay? For the number of customers who use the Gold Card, all right? Now, here's what we're gonna do. We're first gonna talk about the mean. Mean is nothing more than, and I think many of you know this, an average, okay? And in layman's terms, how do we find an average? Well, I think you know this. We're gonna add up all these numbers and then divide by the number of values that we have, which in this case is 11, all right? Now, you'll notice that we have something here, and it's a formula. Okay. And it's really the formula for the procedure that we just talked about, the average. And here's what the top means. First of all, this symbol right here is a summation sign. Okay. What it means is that we need to take all the values in our system here and add them up. Okay. So within this problem, we have 64, 80, 76, 88, so on, all the way to 101. And I want to add them up. Okay, so this means add. And then you have to divide by n, and n is the number of values that we have. Okay, so we can do that fairly easy. That's a very elementary procedure. However, I'm going to show you a little bit different way to do it using some techniques that we used in the past. Okay, so first thing we're going to do is we're going to put all these items in our L1. Okay. And the way we do that, if you don't remember from before, is we're going to go to statistics, which if you look at this first problem, it's that button right there. And then you should have an L1 here. Okay, now if you want to get rid of the numbers in your L1, here's what you have to do. First, you have to highlight the L1. Okay, you have to have the cursor over the L1, and then you need to hit the clear button, and then you need to hit the enter button. Okay, do not hit delete. Delete does bad things. Okay, if you accidentally do that, then let me know. I'll show you a way to get it back. Okay, you'll actually lose your entire list, including the L1. So again, highlight the L1, hit clear, enter, and then input those values into your L1. Okay, maybe pause this for a second, okay, so you can put those numbers in, okay? And then when you unpause it, it'll tell you what to do next. Okay, so once these items are in my L1, right here, I'm going to do the same procedure that I did before. I'm going to go to Stat. I'm going to scroll over one to Calc. Okay. And the first item that you see here is one var stats. Okay, and in one var stats, you're going to input the value L1. It's probably already there. That is your default. And you're going to go all the way down to calculate. And when you hit enter, you're going to look for some things that were a little different from what we had before. In the past, we looked for this x bar, the summation of x. Okay, and now we're going to look for this item right here that says x bar. Notice that matches the x bar that we had in our formula. Whenever you see X bar, that is the same thing as the average. Okay, so this average is represented by that symbol, X bar. All right, now if you look at your calculator, and if I did it right too, I believe you get X bar is equal to 83. Okay, further, we have two more definitions. We have variance and we have standard deviation. Okay. And your standard deviation we'll do next is represented by this symbol. Okay, it's your S of X. Now there is a monster formula for standard deviation, and I typically show you how to use it using your lists. Okay. However, for now, we're just going to use this shortcut method. My S of X says 11.72, and if you round it correctly, I believe 2. All right. Again, there was a formula on the other side. All right. However, we're not going to use that for right now. Okay, we'll just go with this method right here. The last thing is the variance. We call this standard deviation first. Variance. Variance sounds intense, but it's really nothing more than the standard deviation squared. Okay, so what you have to do is you have to take this 11.722 and square it. Okay, and I'm going to do the same thing on my calculator. 11.722 squared gives me about 137.4. Okay, so 137.4, about. Okay, maybe put an about sign there. Okay. Now, what is standard deviation? All right, we know what the mean is. Means the average. Okay, what does standard deviation mean? That's really one word. Okay. By definition, we're allowed to say it like this. It's how far, on average, your data values are from the mean. Okay. How far on average your data values are from the mean. And what that means is this. If your standard deviation is really small, let's say your value is small, okay, like it's close to 0, okay, what that means is that your numbers are close together, okay, your data values are close together. Okay, and that's good. We want consistency within our data. So if they're close together, then when you do this procedure, okay, then you'll find that it actually gives you something very, very small, okay, and that's good. When your data values are far apart, that means you're going to get a very large standard deviation, right? And sometimes that happens. All right? So again, this is the formula. It's not pretty. You're gonna, well, what you'd have to do is you'd have to take all these X values, subtract the mean of 83 to every one of them. You're gonna get 11 answers, and then you have to square the 11 answers. Okay, then you got to add them all up, and then you have to divide by n minus 1, and then square root it, and that takes a long time. Okay, it's real quick to do it on your calculator, and we will use this procedure to get that. Okay, keep this in mind. This is an important definition. Okay, and you're gonna have to know that. Okay, so let's move on. Again, we have Dairy Queen participants here, and it's the same numbers that we had before. Okay, people who use their gold card, and it says create a dot plot. All right, and we've done dot plots. Let's see if I can make this straight. Oh, Rothery. Some things in technology are just too sensitive. Okay, so Let's do this. Let's look at our data and see how many items we should count by. It looks like we have low of 64 users for the gold card for 1 month, and the high looks like it's about 101. So 60, 70, 80, 90, 100. We could go 5. Maybe we'll do intervals of 5 or 10. Okay, so here's what I got. I'm going to do this from 60 to 69 users. Okay. And then we'll say this is 70 to 79 users. This is 80 to 89 users. 90 to 99 users. And then this will be 100 to 109, okay? And these are the number of gold card users at Dairy Queen in 1 month. Okay, so 64 is here, 80 is here, 76 is here, 88, 75, 99, 71, 92, 78, 89, 101. Okay, I'm going to count these just to make sure I have enough. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This I'm going to call frequency. Okay. Notice that both of these have labels, both the horizontal and the vertical axis. That's important. AP doesn't like it if you forget to do that. All right. So here's what I'm going to do. I'm going to answer this question like I have in traditional fashion, describing the distribution using socks. Okay, so here's what I'm going to do. I have S standing for, and notice they don't tell them to you this time, you have to know it, is the shape. All right, now if I'm looking at this shape, it looks like it may be a little bit skewed towards higher values. Okay, this is your peak, kind of like right here, and it seems to work its way down this way, and there's really not much data on the left side of that. So I'm going to say it is slightly skewed right, and I'm going to put this in context. The distribution. When I say context, it means I'm going to talk about Dairy Queen gold cards. Okay. The distribution of gold cards used at Dairy Queen. Don't we all call this DQ? I will too. For any month is skewed, and you may even say slightly. I don't know. There's not a lot of data, so there's okay toward. Okay, and remember we always go to the tail. Okay, so your tail is out this way, higher values. Boom. Okay. All right. O stands for, by this was shape, in case you forgot. O stands for outliers. And by this graph, does it look like this plot have any outliers? I don't think so. Okay. There are no outliers. Some of you are wondering, how do we determine how far a point may be away to see if it's an outlier or not? I'm going to let you know that soon. Okay. C stands for center. Now, here's what I want you to do. I know there's 11, okay, and I can work my way from the outside to the middle. Half of 11 is what, 5.5? So that means I have to go to the sixth one in each direction. So 1, 2, 3, 4, 5. It's the lowest one in the 80s, okay? Or if I went the other way, 6 in this direction, it would be, again, the same spot. So I have 89, 88, and 80. So it looks like the center is 80. Okay, now, here's what I want you to do. I'm going to take a break from finishing this answer. I want you to go back into your calculator. Okay, start over. And I want you to go back and hit Stat. I want you to go to scroll over one to Calc. And that command that we've been doing now a couple times, one-var stat, I want you to hit it again. Okay, keep your L1 in there and go down and calculate. And it's going to give you the same screen that we've kind of looked at, okay, for the last 10 minutes or so. Now, here's what I want you to do. While the information that we have there helped us more with the previous screen, what I would like you to do is hit the bottom cursor, okay? The bottom cursor is this guy. Hit that as far as it'll go, and it's going to give you some information, okay? You'll notice that right here, it gives you the median, okay? And median is the same thing as the center, and you'll notice that it verifies that it is 80, okay? And that's great. So if you have like a ton of data, like say you have 100 data items, and they're all mixed up, put them in your L1 and do a one-var stat, and then do this command. And don't forget to scroll down. People forget to scroll down sometimes. And you can find the median or the center really quickly. Okay. All right, the last one is my favorite because it's super easy. Okay, and it's just the spread. And you just write that, the spread is from, okay, and we're going to pick the lowest value. The lowest value in my 60s was 64. Okay, and then we're going to go to the highest value, which is 101. Okay, and again, I like this because you don't have to subtract. Okay, so do not subtract. Do not subtract. And more importantly, big AP thing here, do not call this the range. Okay, range is when you do subtract. Okay, so don't call this to this the range because they'll mark that wrong. Okay, all right, if there's no other questions, let's go on to a part that you've been anticipating, and that's determining whether a point could be, or a value could be an outlier. All right, so let me look at that same data, and I'm going to give you a formula, and it goes like this. This is your outlier test. Based off the screen that you had on the previous slide, I'm just going to show it to you real quick. When I say screen, I mean this guy right here. Keep that handy. Don't hit clear. Okay. What we're going to do is we're going to look at a couple items. The first one I'm going to look at is my Q3, and I'm also going to look at my Q1. Okay. And if I look at those on my screen, my Q3 shows, I think, 92, and my Q1 shows a 75. So I'm going to write those down. Q3 is 92, Q1 is 75. And here's what I'm going to do to them. I'm going to subtract them. Okay. Now, use your calculator if you like, but I think if you subtract them, I think you get 17. And then once you subtract them, you're going to do this kind of unusual step. You're going to multiply this answer by 1.5. Now, the most common question is like, why 1.5? It's the number they came up with, and you'll learn more about percentages and stuff like that later, but 1.5 is the number that they choose, and you'll have to use that every single time. This is just part of my formula. Okay, you'll never put a 2 out here or 1.75. It's always 1.5. And you're going to have to take 1.5 and you're going to multiply it by 17. Okay, and if you do that, you get 22.5. Sorry, 25.5. So I said the very first day that you may not do anything more than add, subtract, multiply, or divide square root in this class, other than one small section. And that's still holding true. Okay, very easy math. You just have to know this simple formula. Okay. All right, now here's your last step. To finish this, finish the outlier test. Okay. You're going to take this number, 25.5, and you're going to add it to Q3. Okay, and then you're going to subtract it from Q1. Okay, so Q3 we said was 92. So here's what I'm going to do. I'm going to take 92 and add to that 25.5. And let's see, I know that's going to give me a 0.5 on the outside. This is going to give me a 7 and 117.5. Looks good. And my Q1 is 75. Okay. And if you subtract those, you can use a calculator, of course, you get 49.5. Okay. Now here's what I'm going to ask. Those are my boundaries. Do I have any values in my data that are lower than 49? Any values lower than 49? And if I look, no. The lowest we have is 64. Okay. With respect to the higher number, the higher answer, do we have any values higher than that? Sorry, I said 49. I meant 49.5. Okay, and if we look here, 117.5, are any of these data values higher than that? No, my highest is 1. Okay, so there's a no for there. There are no numbers that extend beyond these two in either the upper direction or the lower direction. And because of that, that means there are no outliers. Okay, and that is the outlier test. From here on out, if they ask for potential outliers, this test now has to be performed. Okay, so we kind of had a good break with 1.1 and 1.2. Now we have to represent. Okay, so keep that in mind as you work through new math problems. Okay, now box and whisker. My hope is that you still have that screen up on your graphing calculator. So I'm going to head back 2 screens just for a second. Okay, you need this guy. Okay, so if it's not there still, just go to Stat, scroll over 1 to Calc, hit Enter for your 1var stats. Okay, and then you're going to have to scroll down. So again, Stat, scroll over to Calc, 1var stats. Okay, still your L1. Okay, and then you have to work your way down and hit Calc, I think, and then Enter. Okay, and then you're going to have to scroll down. All right, so it gives me, when you scroll down, a 5-number summary. And some of this stuff we already know. Okay, so we already know what the low value is. We already know what the high value is. We know what the median is because we needed it for describing our distribution. And we also know what each of the quartiles are. So let me write these out just for a second. Where's my pencil? There we go. Let's see. The first thing I'm going to write down is the minimum. All right, the minimum we said was 64. And then the maximum is 101. Your center is 80. These are all numbers we've used in the past. And your Q1 is 75. And your Q3 is 92. All right, so these are important. We found these all. If you ever had to do them by hand, okay, you'd have to remember first to put these in order from lowest to highest. So I think my next lowest is 71. The next lowest is 76, 75, 76, 78. And then we have a couple in the 80s. We have 80, 88, 89. 92, 99, and then 101. Okay. Remember that your median or your center is the middle value. Remember what a quartile is. Okay. Your quartile is basically the median of the bottom half. Okay, of your data. So if I look at all these numbers on the bottom, okay, and I'm not going to include 80 in this, okay, the middle number amongst those 5 is 75, and that would seem to be consistent. And of course, Q3 is the median of the upper half. Okay, again, 80 is not part of it. And so if you look at these 5, there's 92. If for some reason you had an even amount of values in this upper half, then you would take the 2 in the middle and you'd have to average them just like you would with a traditional center or median. Okay. Also, say for example, you had 2 medians, okay, that you'd have to average to get an overall center. Know that if you had 2 that you had to average, the lower number of those 2 would actually fall in the bottom half in order to calculate your Q1. And the bigger number would have to fall in the upper half to find your Q3. Okay. All right, so here's what I'm going to do. And we have to be careful here, all right? I'm going to draw a number line at the bottom here. That's not what I wanted to do. Let me get rid of one of these, or both. Let's try maroon. That is not level, but it's still pretty good. Okay, and here's what I'm gonna do. I'm gonna I know I have to start somewhere around 64 and finish at 101. I'm gonna draw some tick marks. I'm gonna say, hey, this is 60. 1, 2, 3, 4, 5, 6, 7, 8, 9, 70. 1, 2, 3, 4, 5, 6, 7, 8, 9, 80. 1, 2, 3, 4, 5, 6, 7, 8, 9, 90. 1, 2, 3, 4, 5, 6, 7, 8, 9, 100. All right, so I always draw these out first. All right. And then what I'm going to do is for each one of these 5, I'm going to draw a vertical line through those little tick marks. So I will pick gold and I will say 64 is right here. And if I don't have tick marks, you should write 64. Okay. Q1 is 75. Now I have tick marks, so because they land exactly on a tick mark, then you don't really have to write the 75. If they don't land exactly on a tick mark, like maybe it was 75.3 and it's between some spaces here, then write the number above. Here's 80. Here is 92 and 101. All right, now once you have all 5 of those, okay, you're going to take the 3 in the middle and you're going to connect them. This is like a box. And then the 2 on the ends, you'll connect with a line. Sometimes they'll call that a whisker, but this is a box plot or a box and whisker. Okay, I'm going to fill in these others, 80, 92, 101. And again, these are the number of customers. in 1 month. Or I'll just hit a gold card at DQ. Okay. Now, an important feature, okay, is this. Is knowing that each one of these representations are quartiles. I lost it, darn it. There we go. Can't find my cursor. There we go. Okay, so this is a quartile. Remember, quartile has the word quarter in it, and that means we have 25% of our data between 64 and 75. All right. This little area here is also 25%, the amount of data that you have between 75 and 80. Between 80 and 92, I have another 25% of my data, and between 92 and 101 is an additional 25%. Sometimes people think that because this interval here is longer, that there's more data that you would have between these two than maybe something like between the 75 and the 80, because that's really short and narrow. And it's not. It just means that there's the same amount of data that you have in this location than what you have here. The only difference is that this part here is more spread out and this part here is more congested. Okay. So again, big AP multiple choice questions is just the idea of recognizing that each one of these is 25%. Okay. All right. Internalize that. If you have to stop and rewind, that would be fine. There's a lot of information talked there. And again, we got to make sure that we get that. Okay, here's the last piece, I believe. Yep, it is. What I'm going to do is I'm going to look at my data here, and here's what they said. They said, you know what? Dairy Queen made a mistake. Okay, they said, you know what? This 64 really wasn't a 64. The numbers were reversed. It's actually a 46. Okay, it says create a new modified box plot based off our data. Okay, now what I'm going to do is look at this 46 and recognize that this, based off our ruling from 2 slides ago, is an outlier. Okay, 46, okay, is, there we go, 46 is lower than this. Okay, so that would be recognized as an outlier. So what I'm going to do is I have to do this a little bit differently. A modified box plot looks like this. My minimum is still 46, even though this has an asterisk to it, it's an outlier. My median is still 80. My Q1 is still 75. And my Q3 is 92. And my max is 101. So I'm going to make this look just like before. Okay, I'm going to start with 64. 5, 6, 7, 8, 9, 10. So there's 70. There's 80. There's 90. There's 100. Okay, so here's the deal. If you have an outlier, you're going to have to treat this a little differently. Everything's going to look the same except for the outlier. So I'm going to make my 101 still a line like that. I'm still going to put 92 with a vertical line like that. 80, untouched. 75, still here. Okay, now 46, if this is my outlier, then I'm going to have to actually draw this down further. There's 50. 46, I'm going to put a big dot where that 46 is. Okay, outliers are dots. And sometimes you have just one, like we did in this case. There may be moments where you have a couple outliers, maybe some on this side, some on the other side. So I'm going to draw my box using the middle three, just like I said I would. I'm going to draw my tail over here. However, the side that had the outlier on it, I'm not going to draw a line to this outlier. I'm going to draw a line to the data values that is the lowest, that is not an outlier. Okay, so let's think about this. 46 was an outlier. The lowest number that I have now is 71, I believe. Okay, so this will be my low point, okay, for this box plot. And then again, I'm going to identify this outlier with a huge dot out to the left. Okay. So, what does this mean? What was influenced most by this error? Okay, is it the mean or is it the median? Okay, let's look at the median first. Okay, my median from the previous slide okay, I think it was 80. Okay, and then did my median change at all based off this new low number? Did this 64 going to 46 change my median at all? And the answer is no. Okay, and so my new median is also 80. Okay, so the median is unchanged by the outlier. Okay. Now, will the mean change? Well, I can kind of in my head think that it will, but what I'm going to do is I'm going to go to my calculator. I'm going to go to my L1 by hitting Stat and Enter, and I can easily change that 64 to a 46. Okay. And then I have to quit my program. Okay, so second quit. The quit button is right next to the second button. It's just second mode. Okay. And again, you'll hit Stat, scroll over to Calc, and you're just going to do another one var stats. And when we adjust this 64 to a 46, I have a new mean. Okay, we have a new mean, and the new mean is 81 point, looks like 36. Okay, and the mean that I had before was not. I think it was 83. Okay, the old mean from what we did earlier was 83. Okay, so was the mean affected by it? Yes, the mean is influenced by outliers. Okay, so mean is always influenced by outliers, median is typically not. In fact, I would just say they're not. Okay, as long as all you're doing is replacing a low number with even a lower number, or replacing a high number with a new high number. As long as you're not adding more numbers to it, your median will not change. Okay. All right. Now the last thing is this: which measure of central tendency? When I say central tendency, that's just the mean, the median, or the mode. It's just a fancy way of saying that. Is resistant to outliers. Now let's think about resistance. What does resistant mean? Well, if I say my watch is water resistant, that means it's unaffected by water. Okay. So resistant means not influenced by. Okay, so which of these three is not influenced by outliers? Okay, well, we just answered that. We said the median is. Okay, the median, okay, is resistance to outliers. Okay. Something else that was resistant to outliers as you look at this, notice that your interquartile range, that's what this is. Okay, your Q3 minus Q1 is something that we call the interquartile range. Okay, and that is also not resistance. Sorry, it's also Resistant to outliers. Okay, resistant to outliers. Okay. Okay, but your mean is not resistant to outliers. Okay, neither is the standard deviation. I'm just going to abbreviate it. Okay, neither is the standard deviation. Okay. One last thing, I forgot. If you don't mind, I didn't talk about variance. I did. Variance is standard deviation squared. Variance is also not. Okay. All right. Sorry for the bouncing around the slides there. Didn't mean to make that confusing. That is all that you have. All right. Most of this work you do on your calculator, and you make these types of pictures with it. All right. Make sure it's clean. Make sure that you write out your numbers first before you draw in your box plot. Okay. And again, always draw a modified plot, okay, over a regular one, because we always want to identify outliers on our box plot if they were to exist. Okay, so modified means that you're going to put an outlier there when it's necessary. All right. If they say, hey, draw a box plot and there's outliers in your problem, that's assumed that you're going to draw a modified one. Okay. Here's what you don't want to do. Some people like to do this. They like to say, ooh, here's my numbers and here's my 5-number summary. I'm just going to draw this. Here's my median right down the middle, 80. Here's my max, 101. Here's my minimum, 46. And then 75 and 92. And what's the problem with doing it this way? Ah, crud. That may be it. The problem is, and I hope you have that on your paper, because I don't think I can get rid of this, is you don't want to make it symmetric, okay? Don't just draw your box plot in and make it nice and pretty and symmetric when the gaps should be proportionally spaced apart based off their distance, okay? So don't make them all the same spacing if really their distances should be more unique, all right? Sorry I have this, but I really don't know what else to do, so I'm gonna stop this so I can save this and not kill this presentation. I hope you have a great day. If you have any questions, you let me know.